Hello everyone, I'm your teacher Umar. I hope you are fine. This video will talk about bioreactors. Before starting today's lecture, I request you to please subscribe and click the bell icon, like this video. So the bioreactor is a container in which substrate will turn into product by action of biocatalyst. We will use any enzyme or biocatalyst to convert our substrate into product. It can be described as part of a bioprocess since conversion occurs in the bioreactor. Fermentation on solid state water content 40 to 80%, mostly mold agriculture product, food, rice, wheat, barley. Submerged has water content greater than 90% and usually used microbes like bacteria and yeast. Bioreactors can be classified according to their different criteria. Eight types and form of biocatalyst: free cells in submerged culture, carried bound, or immobilized cells enzymes. Mode of operation: batch continuous fed. This is the diagram of a bioreactor. There is an agitation system, feeding pump where we feed a media substrate. The system monitor, sensor probe, thermal jacket to monitor the temperature. This is the reactor tank. This is submerged aerator and the effluent is passed out through this outlet. So basic feature: agitator system, oxygen delivery system, foam control, temperature control, pH sampling, port cleaning and sterilization system. What is agitator? It is classified as having radial flow or axial flow. Three times more water than radial flow. Radial flow impellers are effective at generating high shear conditions. This aid in breaking a bubble but can also lead to cell damage. With the radial flow mixing, the liquid flow from impeller is initially directed toward the wall of the reactor, that is along the radius of the tank. These are the cells and these are the bubble. These are the impellers. Foam control system: excessive foam formation can lead to blocked air exit filter and to pressure build up in the reactor. Foam is typically controlled with the aid of anti-foaming agent based on silicone or vegetable oil. Excessive anti-foam addition can result in poor oxygen transfer rate that can lead the poor fermentation and our product is not formed by the conversion of substrate into product. A sterilization system: there are Teflon membrane or polypropylene housing is used. Sterilization of the inlet air is undertaken to prevent contaminating organisms. Mostly majority the bacteria in the solid state fermentation contaminate our product, so we cannot achieve the maximum uh, uh, and integrate. Foam control system, condenser. The exit air system consists of a condenser, which is simple heat exchanger through which cool water is passed. Volatile material and water vapor condense on the inner condenser surface. This minimizes water evaporation and loss of volatiles. The bioreactor design: there are different types of design: airlift reactor, bubble column, state tanked, for fluidized bed, packed bagged, and flocated cell reactor. Fluidized bed reactors include these are called immobilized or small particles which move with the fluid. The small particle create large surface area for cell to stick to and enable a high rate of transfer of oxygen and nutrient to cell. Packed bed reactor: in packed bed reactor, cells are immobilized and large particle. The particle do not move with the liquid. Packed bed reactors are simple to construct and operate but can suffer from blockage and from poor oxygen transfer. Flocculated cell reactors: they contain cell by allow them to flocculate. The reactors are usually mainly in the wastewater treatment. The stirred tank reactors: these reactors, mechanical stirrer using impeller, are used to mix the reactor to distribute heat and material like oxygen. Substrate bubble column: these are tall reactors which use air alone to mix the content. Airlift reactor: they are similar to bubble column but differ by the fact that they contain draft tube. The draft tube typically an inner tube which improves circulation, oxygen transfer, and equalizes shear force in the reactor. The stirred tank bioreactor or STB is the choice for more than 70% of industrial work through it. Not the best. The homogenization suspension of solid dispersion of gas liquid mixture, aeration of liquid and heat exchange is done through the steel tank bioreactor. It provided with baffle and rotating steerer is attached either at the top or at bottom of the bioreactor. Baffles are usually flat vertical plates which width is about 1/10 of the vessel diameter. Normally 4 to 6 baffle plates are fitted to the inside vessel wall to the aid mixing and mass transfer by increasing turbulence. Unsteady movement of air or water eliminating net space. Volume of air which is inhaled that does not 4 to 6 baffle plates are fitted to inside vessel wall to aid the mixing and mass transfer by increasing turbulence, unsteady movement of air or water eliminating dead spaces, volume of air which is inhaled that does not take part in the gas exchange. The agitated assembly including the seal is often a potential route of the contamination and prevent this problem. The shaft has to pass into the fermenter through a set of aseptic seal. 2 or 3 seals are required to minimize the risk of fermental contamination. The effectiveness of agitation depends upon the design of impeller blade, speed of agitation, and the depth of liquid. The steel tank bioreactor create high turbulence to maintain transfer rate, but this also generates a considerable shear force. Many animal and plant cells are shear sensitive and many animal and plant cells are shear sensitive and excessive stirring in the result in cell disruption. They cause unsuitable without modification and air lift or supported biofilm reactor may be preferred. Since steel tank reactors are commonly used for batch process with slight modification, these reactors are simple in design and easier to operate. The industry still prefers steel tank because in case of contamination or another standard product formation, the loss is minimal. This is the diagram of steel tank bioreactor. The airlift bioreactor RALB are generally classified as a pneumatic reactor without any mechanical steering arrangement for mixing and using the expansion of compressed gas to bring about the mixing. Turbulence caused by fluid flow ensure adequate mixing of the liquid. The draft tube is provided in the central section of the reactor. The introduction of the fluid air liquid causes upward motion and results in circulatory flow in the entire reactor. ALB can be used for both free and immobilized cells. There are very few reports on ALB for metabolite production. Advantage of airlift reactor: elimination of attribution effect generally encountered in mechanical agitated reactor. Fluidized bed have received increased attention in the recent years due to the advantage of other type of reactor. Most of the fluidized bed bioreactor developed by the biological system involving cell as biocatalyst and three-phase solid liquid gas. They are generally operated in co-current full of liquid as the continuous phase. Another unusual configuration like the inverse three-phase fluidized bed or gas solid fluidized bed are not of the much importance. Usually fluidization is obtained either by external liquid recirculation or by gas fed to the reactor. In case of immobilized enzyme, usual situation is of the two-phase system involving solid and liquid, but the use of aerobic biology and the third phase. This is the diagram. The packed bed bioreactor, they used biofilm attached in the wastewater engineering. Diagram. That's all from today. Like the video.